Okay, so continuing with solving trig equations, this is part 2, a couple of tougher examples this time. We're looking at 2 sine squared plus 5 sine x minus 3. We want to recognize what we've got here is something similar to 2 an unknown value squared plus 5 times an unknown value minus 3, so much like 2a squared plus 5a minus 3 equals 0. How to solve this, of course, we would want to factor it. And so in the same way that we would solve that, we'll solve this. Sine x is just an unknown value, just like a was an unknown value in the question here. So if I'm going to use decomposition here, I'm looking for two numbers that multiply to negative 6. Negative 6, if you don't remember, basically we multiply the first coefficient with the last coefficient to get that key value of negative 6. And I need two numbers that multiply to that negative 6 and which add to the middle term, the coefficient of the middle term, the 5 in this case. And so positive 6 and negative 1 are my two numbers. And then I go through the process of splitting the middle term. So again, exactly the same solution as if this were an a or an x, an x squared, an a squared, an x. And, so split the middle term into 6 sine and minus 1 sine. And then find the common factor between these two terms, which is the 2 sine x. I'm left with sine x plus 3 when I factor there. The common factor over here is the negative 1 sine x plus 3. And that gives me that sine x plus 3 times 2 sine x minus 1 is equal to 0. So sine x plus 3 is the common factor for the whole expression now. 2 sine x minus 1 is the second term. I don't know why I missed all the dots on my eyes. Which tells me anytime I have two terms multiplied equal to 0, this term is 0 or this term is 0. Now it's important to note there is that the first possibility, sine x equaling negative 3, is not really a possibility at all. And so the key point there is that because I'm looking for sine x, and sine by definition is the opposite divided by the hypotenuse, hypotenuse being the longest side will force this fraction to always be between negative 1 and positive 1. Sorry, less than or equal to negative 1, less than or equal to positive 1. So this gives an error. Punch into the calculator, you see an error. The reason for it is just, again, the definition of sine. Over here, 2 sine x minus 1, add the 1 to both sides, divide through by 2, and we find that sine x is 1/2. That occurs when our angle is 30 degrees, or pi over 6. And so now we finish up much the same way we did in previous questions. I'm looking for positive values here for sine. CAST rule, CAS. I learned it as all soup turns cold, so they're actually in order. But the first and the second quadrant are the two I'm interested in. And so pi over 6, and then this one over here, which is pi minus pi over 6. We've seen this a couple times now. 5 pi over 6. And so those are my two solutions to this because, again, no possible solutions to this first option here. Okay, one last example. I'll go through it fairly quickly. The real key to this question, the only real difference between it and maybe the last one, sort of jumps out at me right here. I have sine squared x, and then I have cos x in the rest of the question. And so if we think about something with x's and y's from before, this is unfactorable. We of course could factor the exact same expression if we had x squared here and x here. And so what we're looking to do is substitute something with cos in here or something in terms of sine in here. But cos x, of course, is one of those base ratios, probably not something I need to play with too much. So I'm going to look to replace sine squared x with something that has cos's. And the Pythagorean function, the Pythagorean identity from the sections we've just kind of gone through, was this. And so if we subtract cos squared from both sides, we get that 1 minus cos squared is equal to sine squared, and so it can be substituted into that equation instead. Now as I continue through, this will be pretty much the same as the last question. Factor at this point, these are our two factors. The 2 cos x plus 1, if we make that equal to 0, recognizing again, one of these bracketed expressions must be 0. So the first possibility is that this one is. Subtract the 1, divide through, cos x is negative 1/2. That means our base ratio is the x value that gives us the 1/2, which is pi over 3. So pi over 3 into my butterfly. I want the negatives specifically, which means the second quadrant and the third quadrant. And as we've done a couple of times now, this angle is pi minus the pi over 3, and this angle is pi plus the pi over 3. And so those are the two answers there. The second half of the question, cos x equals negative 1, or sorry, cos x minus 1 equals 0, means that cos x will be equal to 1. That occurs when x is 0. And again, calculator will help you figure that out. But if you're not sure why that works, if we think about the fact that if cos x is going to be 1, that means that the adjacent divided by the hypotenuse has to equal 1, which means that my hypotenuse actually has to be the same length as the adjacent. The only way that's going to occur is if it's actually the same line. And now the same thing would occur looking at this angle. If I can shrink this angle until my hypotenuse and my adjacent are the same. Similarly, that base angle has to be 0, and so my butterfly now is perfectly flat. The only thing to recognize there then is that with our cast rule, where cos is positive is these two quadrants. So the angle in here, the line in here if you will, is where we're going to get a value of 1. Over here, cos has to be negative, and so we'd actually have cos of x being negative 1 for the angle, cos of pi would be negative 1. Cos of 0 is positive 1. And just kind of last thing, I don't know what I wrote here. No, just an explanation of that, I guess. Cos is positive in quadrants 1 and 4, so there's only one solution, and that is x is 0. So my final solution, 2 pi over 3 from here, 4 pi over 3 from here, and the 0 from the second part of the question.